अपने पास में डाल ही रहे, चाहे वो हमको वहां भी देंगे।
Okay, so we have already waited for a long time. So let us start our today's session. I hope I am loud and clear.
Yes, yeah.
Thanks. So this is our today's session, NPTEL live session for week 9, and this is the course of non-conventional energy resources, which is taken by Professor Prathap Haridoss from IIT Madras. So I will taking the tutorial and or the live session. So as for my introduction, I am Lalit Bharti, the Prime Minister's Fellow in the Department of Physics of IIT Kharagpur. So we will taking the course syllabus of week 9. So basically, it includes the ocean energy, ocean thermal energy systems, and the biomass. So we will be taking. Yes. So we will taking the week 9. It includes first the ocean thermal energy system. We call it in brief OTES. The geothermal energies, geothermal, and the biomass uses and issues. So we will be taking the problems based on these three topics for today. So we have some previous year questions, some quiz questions of previous week, and some non-graded questions which are available on the NPTEL website. So these questions will help you to clear the content of this course, and also these will be important for your main exams. So we'll take the first question. The use of biomass represent the capture and release of the same amount of carbon, and hence it considered safe for environment. So we need to see if the statement is true or false. So if we see basically what is biomass, so biomass in the energy aspect, we see whatever energy we can get from the biological systems or the living or the organic elements available for us. It can be from animals, from plants, and from other organic objects. So whatever energy we get from these, that comes into the biomass energy. So the statement is use of biomass represent the capture and release of same amount of carbon. So usually because these organic objects, these are made up of carbon. So by using energy, we use this carbon as a source. We either heat it up or we use some reactions, and we get either CO2 or some other carbon and oxygen derivatives plus some energy. It is basically in terms of heat. So this is a very simple form of simple reaction mechanism. So we see that we are starting from carbon and we are again getting some carbon derivatives. So basically the statement can be taken as true. So this is a very rough idea of what is biomass and how we deal with biomass. The second question, if we take the second, these are the just the ungraded questions available on the NPTEL website. Second is the temperature deep inside the ocean is relatively unchanged by the time of the day. So we need to see the deep inside of ocean. So these are two images you can see. These are vertical variation in sea temperatures. So as we go deep down, at the x-axis there is the depth. As we go down, it is shown how temperature varies. So at the surface, temperature is around between 20 to 24, and from 500 to 1000 meters, it is changing very drastically. So change, it is getting up to 3-4 degrees, but after that, the temperature is almost stable, or the change in temperature is very low. So you can see after the thermocline or the 1000 meter, the temperature is around 4 degrees Celsius, and it is not changing. So it is almost unchanged. So we can say true, yes. Temperature in the deep inside of ocean is relatively unchanged by the time of the day. Next, we see the composition of Earth can be determined in part from information on how earthquake waves travel through the Earth. So this is a very basic question. So you can understand it by these diagrams. So basically, in Earth waves, if somebody is from this geology background, they understand these P waves and S waves. So basically, there are two kinds of waves. For a simple manner, you can understand it. In an earthquake, there are two types of waves: P waves and S waves. So they both waves have their different characteristics. So we don't go in very inside or very deep in this earthquake waves, but you can just understand that every wave have some different characteristics in different medium, like in sandstone, in basalt, in solid iron alloy, in molten iron alloy, in liquids, in solids. So solid iron alloy and molten iron. So each wave have some different characteristics. So by studying these waves, by studying these S and P waves, how they travel inside the earth, we can determine the structure or the composition of earth and earth core. So here also it is shown in the right picture. This P wave is indicated by the black line and S wave is indicated by the red line. So how these are reflecting by the earth core? This is the earth core. So by their reflection, only P waves can travel through the core, but the S wave will be reflected out of the core. So by that, by measuring this intensity of these waves, we can determine the structure or the composition of Earth. So this is also true. Now we'll see the fourth question. The fourth question says, cool water from deep inside the ocean can be directly used for air conditioning. So this is also a part of ocean thermal energy conversion. So in the right side, it is shown that how the OTES systems work. So they work basically on the temperature difference. So because at the surface and at the bottom or the deep ocean, there is some temperature difference. It is can be told in this delta T. So due to this temperature difference, we can use it to move a physical or mechanical turbine. So by using that turbine or the generator, it produce electricity. So we will see in next question the in deeply how the structure of this OT or TEC system is, that is also described during your main lectures, which are available on NPTEL website. So we will just overlook it here. So yes, because these kind of systems can be used for air conditioning, for electricity, for fresh water, all these applications. So we'll see. Yes, this statement is true. In the next question, again on OTEC. OTEC based systems are low in efficiency but can be evidently tapped. So again, we understood what is OTEC system, the ocean thermal energy conversion systems. The main issue is the temperature difference is very low. Like the maximum temperature difference can go up to 15 to 25 degrees Celsius. You can see it is the warm water surface is around 20 to 35 degrees Celsius, and cold water, cold deep sea water is 3 to 7 degrees Celsius. So it is around. So due to that, their efficiencies are quite low. But the efficiency are, if you remember from your main lectures, it is the temperature Tc by Th. So this is the Th of warm water and Tc is from the cold water. So it will be around very roughly say around 20 or 20%. So yes, these efficiencies are low, but we have a lot of amount of warm because the sea or the ocean have a plenty amount of water. So we have this energy available very abundantly. So lot of energy. Low efficiency, but lot of energy. So these are two main characteristics of ocean thermal energy conversion. So that statement is also true. Now we'll see the next question. It says OTEC principle is based on what? Between the warm water and surface and cooler colder water at approximately what distance below the surface. So we have already seen that from these four options, the temperature difference will be the correct, because we have seen that OTEC works on the temperature difference. Temperature difference from the hot water of hot surface water and cold deep sea water. So we know that there should be some temperature gradient. So delta T is basically temperature difference, and colder water at approximately what distance. So we have given around 1.5 kilometer, also and around 5 kilometer. So from our previous questions also, we have seen that after 1000 or 1 kilometer, 1000 meter or 1 kilometer, temperature comes around 3 to 4 degrees Celsius, and that is almost constant. But you can say relatively constant. So if the temperature after 1 kilometer is relatively constant, then if it doesn't matter if we go to 1.5 kilometer or 5 kilometer or 10 kilometers, we will get the same temperature. But as we go deep inside, the pressure will constantly increase. So we don't want to be the pressure to get increased, we want at least as much possible as low. So we want it to be around 1 to 1.5 kilometers. Here also the closed cycle ocean thermal energy system, it is shown here. So its depth is around 1000 meters and temperature of water is 4 degrees Celsius. So if you go around 1.5 kilometer, it will be around 3 degrees Celsius. And there is no profit in going deeper. So our option B will be correct. The temperature difference at approximately 1.5 kilometers. Now we'll see the next question. The next question is
Lalit sir,
yes, yes.
just any idea of what will be the generation capacities of such plant?
Generation
What
capacities, because these kind of
like
plants are not mobile. They work at a large scale. So their capacities will be, if you have a rough idea of wind turbines. So if one wind turbine can be from
300,
kilowatts to megawatts.
yeah, 3 kilowatts to
It depends on the size of that turbine, that windmill. So it can be of megawatt also. So it is also the similar way. It is around kilowatts to in range from kilowatts to megawatts. But it depends on the size, basically the size of the whole system. And because they are not very cheap to build, so these are basically in larger size, available in larger sizes. So it can be in 1 kilowatt to some megawatt.
We have any
So
plants
this
in India?
in India, I don't see any ocean thermal energy conversion because these are relatively new technology. So basically, these are mostly in the research phase till now, and this need a huge amount of investment because these are not as readily available as solar energies and wind energy. So India is mostly focusing on solar and wind for at least for few years. And this kind of technologies, mostly the coastline countries which have more coastal area, they are, or they might having more sea and deep sea because it needs very deep sea. If you see in coastal areas of India, there's you will not find very deep sea of 1 kilometer deep. So you will need some very deep sea for that because temperature difference is, until you get temperature difference of this 15 to 20 degrees Celsius, you will not be able to efficiently, because even at there's a question also, we will see that we will calculate the energy efficiency. So still in that it is 20%. So
yes,
that is why we are not in India will not see so much of this kind of technology. But still, it is a very good technology to work because the energy available in that case, because water is sea has very plenty amount of water. So the amount or
we
the
have a
quantity of
very vast coastal line, and
yes,
we have
we
Arabian
have
Sea.
yes, we have good coastal line, but we need very deep, either we deep trenches for that, because for these coastal lines we don't have this 1000 meters or something. So if even if we have, we need a huge investment for that. So I don't see in India, if we are working or we have this kind of systems, we will be developing, but for now we don't have like too many of these. Like it is not comparable to solar plants or the wind plants we have till now.
Okay. Okay, fine.
So our this is our second question. It is a very relatively simple question. Like if a person A and B are moving away from Earth's surface at a location of on the sea, person A is moving toward Earth center and person B away from it. Like if we take it as this is Earth surface. Okay, this is Earth surface. Let's say this is the Earth surface, and person A and person B. So person A is moving toward the Earth surface. This is Earth surface, and person B away from it. Let's say here. So we need to see the what will the temperature. Sorry, what will the pressure? So will it be same? Will it be different? So that is clear also. As deep we go in deep sea, the pressure will be increased. It can you can understand it by the weight of water also, and by simply by intuition you can understand that if the gas volume is 100% at surface, around at 50 meter it will be only 17%. So this is your 6 atm pressure. So the A will, so obviously it will be different, will be more for A than B. So will be more for A than B. So it can be the opposite. Person A is moving towards Earth's surface and person B is away from it. So maybe the question, the answer is not correct in that. So B will facing the more pressure than A.
Sir, excuse me, sir. Person A is moving towards the Earth center. So person A is going down and B is going up.
Oh, I misinterpreted it. This is your Earth center
Yeah.
and this is
So
your
A
Earth
is
surface.
going down
Person A
actually.
is
Your
down,
diagram.
person B is going upward. Okay. Thank you for correcting me.
Then yeah.
This will be
So
the
just saw the question again.
so person A is moving toward the Earth's surface and person B is away from it. Okay. So our third option will be correct. A will be facing more pressure than okay. So this is our third point. Oh, we are not having third question. Okay. So this is our next question. So by the way, Mr. Om Gupta, so can you introduce yourself a little bit so we can have some good interaction, if you like to?
Um, actually, I am an engineering student. I did my engineering in 1990, and
Okay.
then I went abroad. I was working in Mumbai for 10 years, and then I went abroad.
Okay.
Uh, from 2000 to 2018 till Corona came, I was there, and then I came back, and currently I am working as a solar consultant.
Okay.
So it's like a independent freelancer, and I just took this course just to enhance my knowledge, and it is really worth. I feel it is really worth doing it.
Yes, yes. That is very good to actually interact and getting students of very wide area. Like you are working in the solar field and you are taking this course. That is good for you and good for us also.
Yeah, thank you so much.
Okay, so we'll see the next question. This is the general concept of a journey to the Earth center is possible. This statement is correct or not? So these options is or the answer is already given, but we will see that if you go deep inside the Earth core, both our pressure and temperature will increase dramatically or tremendously. So if you see temperature of Earth cores is around 6,000 degrees Celsius. So practically till now we don't have any technology to go deep till this inner core. We have made holes of few kilometers from the these oil industries or from some research purposes. We have done it for few kilometers, but not till the inner core or even the outer core or lower mantle. So because the temperatures and also the pressures, because as you go deep, the pressure will increase in the scale of gigapascals. Even at the 600 kilometers pressure is gigapascal, 23 gigapascal. So it is really very high. So no technology will survive this level of pressures and temperature. So
We we cannot have any apparatus device or something which can stand such a temperature and pressure.
so even around 1,000 degrees, you can survive somehow using some ceramics and all. But because most of our industrial things, the instrument uses metal like iron core or some metal, some alloys. So even this after 1,500, 2,000, your alloys will also melt, and your electronics, whatever electronics you need to control the system, they will even not survive. So up to this 1,000, 2,000, you can use some ceramics or some high high resistive or high capable alloys, but after that it is even not possible. So you can go up to few kilometers. Like we have seen around I'm not sure about some experiments in Russia they have done. They have dig a hole of few kilometers. So around few kilometers, around 10, below 10, you will, even this industry for this gas mining or these gas industries or oil industries, they will dig up a hole of few kilometers. But after that, it is not done by any industries and even by for the research purposes. So getting up to core is near to impossible because it is already 6,000 degrees Celsius. So it is near to impossible. Some people have tried, like if you have seen some concepts, they have tried to dig a hole through earth like in this way. Like
But
not touching
we have been able to get the figures like round figures like 6,000 degrees centigrade is the inner core. Like these
the.
temperatures are through some probes or how they are derived. You say
It
outer
is
core is 3,800.
it is not by some props. Uh, if I try to understand,
Like
mm,
since you are
some
you're a
geology,
research
some
scholar, you can give a better idea.
sorry,
Since you are in research, you might have a better idea how these figures are arrived.
like uh, I just, like some geology people can give a better answer, but I can just assume or I can just think about it. Like we don't have any probes till now for that. So basically these are some research are done. It can be some waves like ultrasonic waves or this kind of waves. How they travel deep inside this earth. So they have somehow pretend or somehow calculated this, so simulated how much temperature it can be. Then they have got it like 6,000
Mm.
degree. And there's many more things. Like if you go in the research field, there are many more things like how these molten core is, how it is, like it is made up of what. So we have found that it is made up of this molten iron. So basically this is iron core.
Yeah.
So they know it, but I'm not sure how the experiments are done. So these are basically done by the geologists. So I can look at it. You can,
Yeah.
if you are
This is
interested.
your
Mhm.
core is HCP iron. What does it mean? HCP
Yes,
like higher.
these are basically this structure of iron. Like HCP is hexagonal close packing. So if you go and pick, even at school levels or your BTech level, so you will see
Mm,
the crystal structures of a system. So there are
mm,
various type of structures. It can be BCC, it can be simple cubic. So basically, these are simple cubic, BCC, body centered, face centered, and HCP.
FCC,
So
HCP.
there are many families of crystals. So these are crystal structure.
Okay,
So what
okay.
happens? Usually HCP, usually iron is not in the HCP state. This is either BCC or FCC. but at very high temperature and very high pressures, iron gets the structure of HCP. So it is possible on the inner core only.
This is a graphite structure. This was
Yes,
HCP.
yes, it is hexagonal close packing. So it is kind of layered, and it is also found in some carbon structures as you told that graphite. Graphite is basically
Graph- Graphene.
layered. Graphene is completely layered structure. If you see, graphene is something like this. It
Yeah,
will be
yeah,
one,
like
and then there will be another layer. So there will be some gap between two layers.
right.
So that is, and graphite is like this. And either I can some diamonds. The diamond has also some different structure, but the iron gets its HCP or on some very high pressure, high
Okay,
pressure and high temperature. So that is why it is mentioned the iron HC.
okay.
So
Thank you.
if we get in another class, I will just surely just tell you how the experimentally they have done it. Okay, I will try to find it out.
Okay, sir. Thank you.
So okay, so we now got at our fifth question. This is geothermal energy is tapped near faults because there is high temperature, low temperature, or what is easy to accessible. So if you see geothermal energy, it is very easily understood that we need higher temperature of pressures. So higher temperatures because geothermal depends on thermal means temperature and geo means we are taking the temperature from our earth, the core of the earth or just deep inside the earth. So this is basically the temperature, but and high temperature. But we see what are the faults. So here in the picture, the faults are shown. Again, it is the if you go deep in the subject, it is the very much geological aspect. But you can just simply understand by these three pictures. So we have in Earth, we have this kind of different tectonic plates. So you see most of the this geological activities are near the plates because all the earthquake you see or tsunamis due to the earthquake they are near the tectonic plates. If you have heard anywhere in the news also, like this is uh, earthquake prone area, like Japan is on earthquake prone area. So that is because underneath the ground the tectonic plates are interacting with each other. So let's say if this is one tectonic plate and this is another tectonic plate. So when they move upon each other, when they touch each other, they create some vibrations. So this that is basically the earthquake. So they can move in different way, like in opposite, going opposite, like going in facing each other, like going side by side. So that is called normal fault, reverse fault, strike, slip faults. So due to this, many geological or geothermal interaction is also present here in this area. So if you see, if they move relatively each other, they will get some friction, and due to this friction, there will be rise in temperature. And if nearby if any water stream is there, so we will get some hot water there. So from friction, you will get some temperature. Temperature increase in temperature. So basically, our question is very much understandable from simple intuition, like high temperature we need for the geothermal energies, but we can also understand what is the faults. So for describing what is faults, I have used this image. So we'll see the next question. This is we need to match the A from this 1 to 3. So we have hot water, superheated steam, and saturated steam. And we have flash tank, directly running turbine, and binary fluid cycle. So one you can directly like super heated steam you can directly connect to directly run turbine, because turbines are mainly run by steam. So if you have superheated steam, you can directly run a turbine. So turbine have a structure something like some cups. Like if this is your center and these are your cups. This is a very simple diagram, but you can understand by that. And we have, if you can get steams from somewhere, so if you have some nozzles, these are nozzles. There can be multiple nozzles, and they will shoot up some jet stream. So it will rotate the turbine and you will get some mechanical energy. Then by using this turbine attaching to some generator, you will get electricity. So these option B is clearly understandable. Option A is the hot water and saturated steam. So for hot water, we need this binary fluid cycle. So because hot water means we don't have too much heat in that water, just it is just relatively hotter than the colder counterpart. So if we have some hot water streams here, so here it is shown the binary cycle power plant. Binary means there's some inlet, some outlet, and due to the difference in temperature, this hot water will go upside. It will run the turbine, and it will get cold, and again it will come downwards. And from this downward, we have some heat exchanger. This is basically the heat exchanger from any source. So it can be your earth core, the earth surface. And so from the inside the earth surface, you will get the temperature back. So that is basically running the turbine. So this is binary cycle power plant. So hot water to binary cycle power. And saturated steam, you can, if you have some steam, it is not superheated, you can use the flash tank. So all three I have just shown briefly here because it is described in your main lectures. So if you go to main lectures or your PDF of main lectures, you will find in details how flash tank works, how binary fluid cycle work, how directly run turbine works. So it is a simple introduction here on.
Sir,
Yeah.
one saturated steam is basically the steam which goes above 100 degrees centigrade, and then it has water droplets, or like how is it?
So saturated steams are like these are around 100 degrees Celsius. So these are saturated, if you see, or but your steam
So the
superheated
temperature of saturated steam will be
temperature
higher.
is
Will be
superheated steams have higher temperature and higher pressure related to
okay.
saturated steams. So we can still run these turbines by saturated steams, but flash tanks are more suitable for that because superheated steams are suitable for directly run turbine. So this question is basically just how relatively they can be attached to these systems.
Okay.
So these are basically the additional attachments. So additional attachments, if your generator is there, your turbine is there, you will be having some additional attachments with that main system. So it can be either binary fluid cycle, it will be between the heat exchanger and your generator. It can be either flash by direct run turbine or binary fluid cycle. So it is very well described in your main lectures. So if you go through that, you will very well understand this.
Okay.
So this is the seventh question is the use of biomass as fuel impact food production. So again, this question is very easy to understand. Like there are four options. True, since agricultural land is limited. False, since the agriculture crop used are not necessarily the same. False, since the crop used are the same. false, since the energy produced can be even more food. So whenever we get this biofuel, biomass as fuel, we need some biological or some biomass, like some objects, some organic objects. So basically, mainly our sources is the plants and the plant waste. And plant or our let's say it, crop waste. So whatever we consume after from a crop, whatever is left, that is used as source of biomass and biomass fuel. So, but the demand of fuel is very high, and limiting factor for this is the land available, because we cannot grow more from a limited amount of land. So we need a higher agriculture land for higher amount of this biomass. So due to this limited agriculture land, we will be having, yes, it will impact the food production. So either we can have plants, or we can have crops suitable for biomass. So since we have limited agriculture land, so if we need too much of biomass as a fuel, we need to compromise with our main food production. But we don't want to interrupt our food supply. So that is why this biomass is still not competing with our petroleum products like petrol or diesel. So yes, our option true. This option 1 is correct. So let's say the next question. It says a banyan tree's lifetime is 300 years. If it is fully grown tree, and if it is burned a thermal plant in a thermal plant to generate energy, and a new tree is planted at the same time, so what will be the impact? So the options are: the process is carbon neutral, is immediate in time frame of only after many years, no carbon is involved, no oxygen. So basically these two options are correct, because carbon and oxygen is always involved in any thermal reaction, because this plant is organic, so it is made up of carbon, and whenever it will react with oxygen only, then we will get some heat and some CO2 or CO. So if this is a fully grown banyan tree, it will be emitting, or it will be giving us some amount of oxygen, let's say O. So its lifetime is around 300 years. So let's say it takes around 100 years to mature. It can be less or more, but just take it. So it is again simple that if you cut this tree and get some energy, you need to wait for 100 years to be able to get equal amount of oxygen. And the carbon neutrality, whatever carbon dioxide you have emitted in the atmosphere, you have to take for 100 years to get it back. So the option 2 is correct. The process will become carbon neutral only after many years. So if you burn this plant in a thermal plant, whatever CO2 you get, you have to wait for many years after planting a tree. It need to be get matured, and it need to emit enough oxygen after so many years to get carbon neutrality. So your option will not be, it is not the immediate, it will take too many years. So option B is correct. This is our question 9. Again, this is based on the turbines and whatever coatings we use. So question says turbine blades are coated with blank to increase blank and to reduce blank of blades. So basically the blades are made up of alloys, metal alloys. So it can be of some aluminum, some iron, and some additives. So basically it is alloys. So due to it is metal based, so they are prone to corrosion. So a very big factor is corrosion. So we need to reduce this corrosion. So one technique is to use a appropriate material like some additives in the metal itself. So to increase the lifetime, so here it will be lifetime. So increase the lifetime and to reduce the corrosion, we need to coat it with something. So here we have given two options, ceramic and metal. So we will not use metals because it is already metal, and metal alloys are always better than metal because alloys are itself are mixture of metals. So we'll not use metals, so only ceramic is the option. So ceramic. So ceramic, lifetime, corrosion, and one is abrasion. Like we need some physical strength. So because using the turbines, they will be prone to wear and tear. So one is the corrosion, one is wear and tear. So we need to make it strong. So we can use some strong coatings, which is stronger than the the alloy or the metal itself. So we can use the ceramic. So ceramics are harder than metals, and ceramics can withstand with higher temperatures. So for the abrasion also, we will be using ceramics. So our option second and option fourth is correct.
Sir, do you have some other questions like on the same subject from the previous year, or just
These
to
are
have
these are these 1 to 10 from the ninth question. These are previous year quiz questions. So
so these
these
are
were in
previous.
basic quiz.
Okay,
Okay.
okay.
And similarly, you have some quiz in this year also. So because the deadline for submitting the question is still not done, so what we'll do, we will take those question in next week. Like
Okay.
this is your week 9. So after that, we will be discussing the week 8 quiz questions because their deadlines are gone.
Over. Yeah.
So this is our next question. Like if the water boils at 100 degrees Celsius at 1 atmosphere pressure, then what will be the boiling temperature at 2 atmosphere pressure? So whether it will increase, whether it will decrease, or what? So first we'll see how a water boils. So if you have some water, let's say some container. So what is the boiling temperature? So from your school knowledge, if you remember, the boiling temperature is when, because every liquid, it is if it is some liquid, it has some vapor. Okay, some vapor present at any temperature. If even at your room temperature, you have some vapors. Let's say it is the interface, you will have some vapor. So when your vapor temperature, no sorry, vapor pressure, let's say it it becomes equal to your atmospheric pressure. So what will happen if you heat this container? So your liquid will start, your liquid will start vaporize. So your vapor pressure will increase. So at T1, if there's some vapors, at T2, your vapors will be higher. So at some time, your vapor pressure will become equal to your atmospheric pressure, like 1 atm. So when it gets to equal to 1 atm, your liquid gets starting boiling. Okay. So you need to make it equal to your atmospheric pressure. So here it is shown that if you need at 2 atmospheric pressure, so your pressure is also increased. Your atmospheric pressure is increased, so you need higher temperatures because your vapor pressure need to be equal to 2 atmospheric pressure or 2 atm. So you need to heat it more. Let's say on T3, you need to heat it more. You need higher vapors, and you will getting higher temperatures. Your T3 will be higher than T2 than T1. So in that case, you will be reaching around 120 degrees of temperature to boil the water. It is also shown here for your, because it is given in kilopascal. So at 100 kilopascal, it will be your 1 atm. So at your 1 atm, you need around 100 degrees Celsius. If you go around 2 atm, like 2 atm is here, you will be requiring this 120 degrees Celsius. So that is the main reason why if you see at higher altitudes, your boiling points or your boiling temperatures changes. And if you go deep inside the sea, which is like not practical, but theoretically, if you go, your boiling temperatures will also change. So these changes with the atmospheric. So it will.
Hello.
So this was the 10th question. These were the previous year's quiz question. Now we have
वो इसके अलग का बिजनेस है ना, फैक्ट्री है उसकी, तो हमने कहा कि मेरे हस्बैंड को बताओ, तो उसके हस्बैंड बात कर ले, भी बात कर ले, हम बता देना उनका कुछ अगर यहाँ कुछ हेल्प कर सकते हो तो बड़ी अच्छा कुछ।
Okay, so there is some network issues. I am trying to resolve this issue. Okay, so sorry for the disturbance. There was some network issues. Let me check. Okay, I hope now it will be good. I'm audible, right? Yes, yes, I guess so. So this was the previous week's first question from week 8. So they need to be submitted by you or before some date. So their submission dates are over. So we can discuss these questions. So basically, we are here to just give you the answers of previous week. So the first question was, how does solar energy affects windmill operation? So the solar energy affects air density and impact weather pattern, enable natural convection, impact on has no impact, and has the blade which makes them generate electric basically on photovoltaic effect. So in windmill we don't have any kind of photovoltaic effect because this is basically for the solar energy generation like solar panels. And we the option 3 is also not correct because it is saying that no impact, so it is also not correct. So we have two options. It affects the air density and impact weather pattern. So yes, definitely the solar energy or the sun affects our weather and also affects the air density. So how it affects? So if it is your earth, so near the earth you have some atoms. So what will happen? Your earth will get warm with the sunlight. So the temperature is higher here. So this air near the earth will get warm and it will get up, try to rise up. And similarly, if this is the cold air, it will go downwards. So it will give some kind of circulation of air due to the changes in air density. So the option A is correct. Yes, solar energy will affect that in that way. And solar energy enables natural convection. So that is also correct because due to the solar light or sunlight, our Earth's natural winds, because if it is your sun, your equator will get hit directly by the sun. So the temperature in this region will be higher than your pole. So due to this temperature difference and also the Coriolis forces, because Earth will be always rotating, let's say it is rotating in this direction. So due to the let's say it is rotating in this direction. So your wind or your wind currents will be affected by sun and your rotation or your Coriolis forces. So it will be something in this direction. This is your wind direction. So these are helpful for our wind powered energy generation. So that is why the solar energy affect the wind energy or windmill operations. So both options A and B are correct. Your option 2 is when a lift type horizontal axis windmill experience wind crossing it, blade tip will move with more speed than the position at the middle of the length of the blade. Yes, correct. And blade tip will move with more velocity than a position in the middle of the length of the blade. That is also correct. Blade tip will as well as position in the middle of the length with the blade will move with same velocity and with position in, okay. So basically if you have some vertical, okay, some in vertical also and in horizontal also. This is case, this is same for both. So they are just asking if this is your center. This is your center and these are your tips, blade tips. So if they are rotating, the speed of blade tips and what will be, let's say it is your tips and your ear at your speed of center. So what will be higher? So if you can easily understand if they are rotating, let's say in this direction, your center will be facing because it has some radius r while rotating. So your center will be at rotating at lower speeds or velocity. So in one option it is given speed and one option is given velocity. So basically these are both are same. So your tips will be moving faster than your center. Same in this case. If it is to take this edge, here it is edge. So your V edge will be higher than the center. So both option 1 and 2 is correct. The option 3 is wind speed approaching a windmill is typically equal, more, less, or zero. Let with the wind speed after crossing the. So if this is your windmill, so there is some wind. Let's say V with V1 speed, and after that it is V2. So it is already distorted by the windmill itself, and some of the energy is transferred to windmill. So if you say some energy E is transferred, then V1 is equal to, or V2 is V1 minus. So if energy is higher, their speeds will be higher. So V1 will be higher than V2. Or wind speed approaching windmill is typically more or higher relative to the wind speed after crossing the windmill. So that is also clear from this image. That will be more. Let's take the next question. Question 4. In an aerofoil shaped kind of windmill blade, pi of the air molecule at the top and bottom is path traveled, wind speed, pressure experienced, different. So we have multiple options. So if we take this path traveled, we take wind speed. So we will one by one take all three options. And pressure experienced. So in a aerofoil shaped kind of windmill blade, if you take a path traveled by the air molecule at the top and the bottom is, obviously it is different. So be it be a vertical or be it be a horizontal. So if it is vertical, so we are talking about blades here. So it is not easy to draw a blade. So it will be having some curve. Let's say this is some blade. So due to the aerodynamic shape, we need pressure difference above and below. Let's say it is A and B. So due to the pressure difference only, we will be getting some mechanical energy transferred to this windmill or this blade, and it will rotate our system. So the same case is for your aeroplane wings. So how they take off? Because the shape of the wings are like that, they will face by moving in the air, they will face some pressure difference at above the above the wing and below the wing. So if above the wing it is lower and below the wing it is higher, they will face a uplift. So if this is your aeroplane, it is very simple image. So, and this is your wings. If you have higher pressure, lower pressure here, higher pressure here, so they will get the uplift. So same happens with the windmill blades. So their path traveled will be different. Also, their wind speed at low, at higher, at above and below will be different. Similarly, again the pressure experience will also be different. At one side the pressure will be higher, at one side it will be lower. And fourth option is path travel is same. So that is not correct because it should be different. So all three options are correct. So the next question. All windmills can function throughout a day, year, season, irrespective of their location. The statement is always true, always false. True if wind speed are within the acceptable range, and true if sunlight is within the acceptable range. So we cannot connect this with sunlight because we directly don't have any relation. So the option fourth will be correct. Incorrect. So any windmill works in some certain scenarios because it needs the wind speed in some certain limitations. Like wind speed should be enough to rotate the blade. Should be enough to rotate the windmill. Okay. So it is not always true, not always correct, but true if the wind speed are within the acceptable range. So that is the main point. So option 3 is also correct. The next question is windmill with 1, 2, 3 or long blades satisfy the conditions for high torque and reduce psychological impact on people near the site. So in our previous class also we have compared one blade, two blade, and three blade, and also we compared this four blade system. So we saw that distortion is the torque resistance is very much required and very much. So for one blade, due to its uneven or non-uniform design, so torque applied on the system or applied on the system was very high. So the one blade design was not the perfect design, no, neither this blade 2. So our blade 3 design was the most acceptable design. So because it will give the least amount of torque on this on main stand of your windmill. So our 3 long blade system will satisfy the condition of high torque and reduce the psychological impact on near the because it looks like safe.
नहीं ये नहीं लिखा मैंने बोला मैम मुझे reading नहीं
So our 3 long design will be most acceptable design. So we discussed this in our last week's question. Why 1, 2, 3, or in 4? Why this third blade is very much required, very much acceptable. So our 7th question is, because these questions were discussed in previous week, so we are just overlooking and giving you the answers of previous quiz. And if any doubt is there, we will be looking at that. So the 7th question is, while manufacturing blades and other parts of windmill, it is important for us to think some 2-3 decades down the line for safe disposable, possibility of recycling, environmental impact of large scale distribution uses, natural color enhancement. So it is again simple to understand that color enhancement we are not looking, because it is not the reason of any concern, but this safe disposal, possibility of recycling, and environmental impact and of large scale and distribution users. These are the main points of main reasons of our concern. So we will not be looking at the color. We will be looking at all 3 options. Option 1, 2, and 3. These are correct. This is the 8th question. Increasing the height of the windmill tower will increase the cost of the infrastructure, decrease the wind speed faced by the blades, increase the power generated, and increase the wind shear. So as if we have some windmill or some windmill system, so if we increase its height, because at surface, near the surface, these speeds are low velocity of air, where if you go at some height, your speeds are higher. So that is why we are building more taller and taller windmills. So wherever our speed or wind currents are high, we will be putting or we will be attaching your wind tower with higher heights. So first, obviously, if it is higher tower, your overall cost will be higher. So you will need more material. You will need more stability. You will be requiring higher cost to fulfill the project. So for higher height, the cost will be higher, and wind speeds will be also higher at higher altitude. So increase in wind speeds, so decrease will be incorrect. So if you have higher wind speed, your power generator will also be higher. And due to your wind speed, it's higher, and your wind share is depending on wind speed, so your share will also be higher. So all 3 options are correct. Only B is in second option is incorrect. So according to Bates limit, length is the upper limit of wind energy captured by a horizontal and vertical. So we have seen in our what is the Bates limit. We have also already seen in our previous lecture of where we will be discussing the windmill and power generated by windmills. So Bates limit is the theoretical limit, the highest limit which gives us the energy efficiency. So it connects the energy efficiency, and this limit is the highest theoretical limit to convert energy from wind to our electrical energy. So if we have 59% of Bette's limit, means from our wind only 59% we can convert in electrical energy. So that is basically a theoretical limit. Theoretical maximum limit of energy generation by a windmill. So it is already given by Betts for both horizontal and vertical. So for horizontal, it was given to be 59%. So or 59% is. So in this course, I don't think so. The whole derivation is given how we get 15%, but it is indicated that 15% is for the horizontal axis windmill. Then we'll see the next. If V1 is the wind velocity faced by windmill blades and V2 is the wind velocity after passing the. So if this is your windmill, it is a very bad image, but let's consider it is a windmill. And it is your V1, it is your V2. Then what is the significance of term V1 by V2? Alpha. Option is wind after crossing the windmill is more than the windmill before the windmill. Wind speed before and after within the windmill is same. So we have to see from this alpha factor. So if your alpha is equal, it is given to be -1. Then your V1 is comparable to V2 or it is equal. Only was -1. So minus will be giving you the direction. So it is saying that your V1 is equal to V2, like your speed before and after is same. So option 2 is correct. It is indicating that before and after it is same, and because they have some minus, so there is minus sign. Wind hitting after reversing the same speed. But in practical, it is not possible because your V2 will always be lower than V1. But it is transferring some energy to windmill, and when we are getting the energy as electrical energy, and energy is always conserved. So V1 will not, if the windmill is moving, in that condition V1 will not be equal to V2. So it is not the same. Option 2 and 4 is correct. So these were the questions. Most of the questions we try to follow and we try to solve. This is for week 9. So as we have 20 minutes to finish this class. So I am here for 20 minutes. If you have, if anyone have any issues or any doubts in this problem, whatever we have discussed, so you can put your doubt and we can discuss on this within this time. These were basically your week 9. So if you don't have any doubts, you can also leave. Or if you have any doubts, you can put your doubt here, and I will be here by 9 till 9. And after 9, we will be wrap up for today, and we will meet at the same time on next week with these week 10 problems and week 9 quiz problems.